Computer. Good morning or good afternoon, everyone. Welcome to today's webinar. This is part of our ongoing series, UST Training, hosted by me, Ben Thomas, is providing these free monthly technical webinars about underground storage tank solutions. We are a solution-oriented company. We do online ABC operator training at usttraining.com. Many of you know me. I've been in this industry not as long as our esteemed speaker, Danny, here, but I've been doing underground tank stuff since the mid 80s, and I'm very excited to be here today. I love hanging out with solution-oriented companies, and it's a great privilege of mine to introduce Danny Brevard of Dri-sump. And as many of you know, sump testing has been required for many years. Sump testing is in fact a good idea because sumps leak, and Danny has pioneered a solution that is quite unique and very different. Maybe Danny will talk about some of the alternative methods, but it's one of the more kind of interesting and innovative, and I think at least impactful method that's out there. And so I think what I want to do, Danny, a quick introduction about you, and then we'll pull up your slides.
Well, thank you very much, Ben. Yeah, I'm Danny Brevard. I've been in the industry about 38 years. I'm a professional geoscientist, so that means that I play in the dirt for a living. And I think sometimes I'm older than dirt, so it seems like it. I've worked I'm pretty active in our industry. I have been on RP 1200 since its inception in about 2009, Ben, 2010.
Wow. Okay.
And I'm also on RP 1700, which is the tank removal. I've done tank removals and subsurface investigative work since the beginning of everything. I've worked in all across the United States and several other countries, Azerbaijan, soil gas analysis, groundwater studies in Senegal. So sustainable development program in Costa Rica. The Maquilador program down in Mexico. So I've been in the industry, enjoyed this. My forte is probably soil gas analysis and the Vados zone, which is down to the first water-bearing strata. And what I specialize in is leak detection forensics. So I'm an expert witness across the country. It's a lot of interesting cases that I get involved in, and that's a whole nother story. And so the other thing that I do is I develop test methods. In 1988, I developed one of the most exciting test methods at that time, which was a vapor monitoring system, and it was called gas system. It's still in operation even today in some states. And it's basically you can take a room full of gasoline and determine if more fuel is coming into that room full of gasoline. So it's very, very accurate. Developed a statistical inventory reconciliation program called SIR Made Simple. And then obviously my biggest endeavor was the Dri-sump system. And we'll get into that whenever we get into the study of it. But I certainly appreciate you, Ben, for allowing me to visit with everyone today. And thanks everyone for showing up. And I hope you get something out of this.
Great. Let's, Danny, I'll have you pull up your first slide. For those joining us, microphones have been muted. Please use Q&A to type in your question for us, and I'll try to answer them as we're going along if it seems kind of timely, but we'll save some time at the end for Q&A. Okay, take it away, Danny.
All right. Well, in developing the Dri-sump test method, it took 5 years to develop this technology, and we'll get into a little bit of that as we go into this. And obviously, whenever you're looking at something from a scientific standpoint, we want to look at goals and how to develop and why are we trying to do this and what is the best method and what's reproducible and things like that. So one of the biggest points is that testing should solve problems. It shouldn't create them. And so the regulations, if you'll go back to the very beginning of this in the early 80s or mid 80s, they were created to protect our water, our groundwater. And we were getting, realizing that fuel could get down into the soil and eventually get into groundwater. So obviously that's not good. So one of the things that we wanted to look at in our training was what is the best matrix to use for testing, and is water the best matrix? Is it the product that we think we can get the best results from?
And Danny, if I can jump in for a minute, I remember many spirited conversations back when the 2015 rule changes were being developed by EPA, and I warned EPA saying, we're some testing is good, but man, I mean, limiting it to a hydrostatic test, you're going to create just a staggering amount of wastewater, which is going to be a huge handling problem. So yeah, I remember those conversations very well.
It was, and obviously it all kind of started back in 2010, whenever the Petroleum Equipment Institute created the industry standard called RP 1200.
Yeah.
And that document was all about testing and testing procedures. And obviously one of them was testing sumps. And in those days, the only way to really test a sump was with water. And so we wrote that as the industry standard, even though it might not have been the best standard, it was certainly the standard. And it was a relatively simple test, and it's a hydrostatic test, or some people call it a lake test. It's pretty simple. You fill the sump with water. You wait about 10, 15 minutes for the water to settle. You measure the water level. You wait an hour. You measure it again. If the level drops an eighth of an inch or more, then the sump fails the test. So it sounded pretty simple. And then, like you said, Ben, in 2015, the EPA made a huge rule change. And one of the things, whenever they do make a rule change, they have to do a study and do a cost analysis. And in those days, just like now, we had about 550,000 fuel tanks. So from their estimates, they determined it would take about 120 million gallons of water to perform that containment test at a cost of about $245 million to properly dispose of the contaminated water.
Wow.
So that was on an annual basis, and obviously we get in this a little bit, but nobody wanted to test with water. And if you look at it, testing with water, it may not meet one of the main requirements, which would be protective of human health and the environment, even though it's an industry standard. Because if you just had a 5% test failure rate, that's water that would be leaking, that eighth of an inch water that's dropping out of that sump. Where is it going? It's got to go somewhere. It doesn't just disappear. So you've got that's 6 million gallons of contaminated water that would be released into the environment in some shape, form, or fashion with just a 5% test failure rate. And we know that in the beginning the test rate was, significantly higher than that. So there is a cost that we have to look at whenever we were doing our study. Let's see, what is the cost? And one of the problems with testing with water is, as you can see, is corrosion. These are some of the original EPA photographs of corrosion of metallic parts that are inside the tank. And so obviously anything that's, some of these may be chemical reactions, but a lot of them are water. And, with this type, you're going to see system failure. The next thing is, obviously, we talked about that. It only takes 1.3 ounces of fuel in 10,000 gallons of water to increase it 1 part per million.
Hmm.
And if you're into subsurface investigative work, you know that we deal in some cases in parts per billion. So that would be an action level that would require some type of action on the part of the regulated community. So here again, that's a lot of water that we're raising that part per million. So contamination, it does harm our environment. And the third thing is that water and fuel don't mix well. Nobody wants to have any fuel in their water if they're in an airplane. It could be pretty deadly. And you see things like in this general aviation use all the time, where a pilot seriously was injured due to water and contaminants in his fuel. So this is not an uncommon thing. So it's inevitable that if you're using water as your test matrix, it's going to find its way into that stored fuel in many cases.
I,
Uh,
I want to throw in maybe a fourth thing. I know we have some service providers on the line. There is a mechanical logistical challenge of towing around a big trailer full of clean water, and then can you reuse it at the next site? And so I mean there's just the physical a logistical problem of managing all that water just from a tester's perspective. Someone did ask if the slides will be available. This is being recorded and will be available on YouTube afterwards.
well, and you are right. I mean, you have to carry that water around. Not all of it comes out of a water hose. And then even if it does come out of a water hose, you have to empty that sump after you get through with the test.
Yep.
And that takes time and effort. And then what do you do with that water? It has to be disposed of in some safe manner. Um, and so we started looking at, well, who uses water to test? So if you have a roof leak, do you use water to test the roof? No, I
That's
mean,
funny.
even in plumbing, water is not the preferred matrix to test. It's usually air. Obviously the problem would come in with underground storage tanks and sumps specifically is you can't pressurize those. They're not designed to hold pressure. They don't have a lid over the top of them. They don't have a way to seal it. So we had some things that we had to overcome. But the cost of testing with water, it seemed to be rather expensive. It could be harmful, and obviously it could be deadly. So that's a lot of liability. And for everyone, the tank owner, the tester, and obviously the regulator. So let's look at that leak, that 1/8 of an inch. If you think about it, most of our tests are based on a gallon per hour loss, and in the case of sumps, it's usually it's 1/10 of a gallon per hour loss would be the leak rate that we're looking for. So if you compare the 1/10, of a gallon of a GPH, one GPH, then if you look at that, a spill bucket, it's approximately 12 inches in diameter. If you do some simple math, you figure out how many cubic inches are in that 1/8 of an inch, you end up with something under 1 gallon per hour is 0.061. So you could easily do a spill bucket and do a hydrostatic test on a spill bucket in with a 12-inch diameter top and do that test within 1 hour, and you could conceivably say that it was meeting a 1/10 of a gallon per hour loss.
Hmm.
But most of our sumps are larger in diameter. So you've got 36 inch, 48 inch. And if you look at that, just look at the 36-inch diameter sump, that would be the equivalent to 0.551. So it would actually take 5.5 hours if you were trying to do the equivalent of a 1/10 of a gallon loss per hour. And nobody's going to sit around for 5.5 hours to test a sump and see if you're losing that 1/8 of an inch. It's not feasible. So that was one of the things that we came up with. If you'll notice on the left-hand side, you see there's a little brass fitting. That is, and there's a penny there so you can see that is a precision orifice, and it's used in EPA testing to calculate leak rate whenever you want to simulate a specific type of leak. So we found there were some limitations in hydrostatic testing, and these are the four main issues that we came up with. 1 foot of water creates 0.433 pounds per square inch. So head pressure is going to be a significant factor in testing with water. The 1/8 of an inch thickness is going to be it won't equal that 1/10 of a gallon loss per hour in a 1 hour test. Groundwater was not discussed in RP 1200, but it's definitely a significant factor whenever you're doing a hydrostatic test because it can actually mask a leak. And then the fourth thing is the certification for hydrostatic testing. Is there something like that similar to other types of test methods like tank testing and line testing? So, and some states do and some do not.
I mean, the certification standard, Danny. I mean, you've got a Sharpie, a stopwatch, and a bunch of water. That's about it, right?
Yep, you gotta tape measure. That's about it. So it doesn't take a lot of the equipment's simple. The process and if you're going from putting that water in the sump to disposing of that water is not as simple. One of the things that came through the regulations was the low-level hydrostatic test method, which basically is an inspection. And then you're trying to measure with enough water, about 4 inches of water, that would be enough to see if it sets off a sensor, a liquid sensor. But if you look at the math, you can see that 4 inches of water doesn't give you enough head pressure
Oh,
to to do anything other than to set off that um, sensor.
I mean
So
that
let's
if I may, Danny, that method is really not that's not a sump tightness test. That's a will a sensor activate test, which is it's kind of apples and oranges. Would you agree?
correct. It really is, and many states don't even accept it, or and if they do, they want a complete full shut off if one of the sensors does kick. So that's that there are some caveats there.
Great. Reggie did ask, I don't know if this is going back a little bit, do you have any sense about the percentage in the US of sumps that have never been tested? Do we know? I mean, best of your knowledge, most, all, some's been tested nationwide. You've been all over this country.
Well, my gut tells me, Ben, that probably somewhere around 50% of the sumps have probably been tested.
Oh, that low? Okay.
Yeah, it's and the reason why is it's the regulations in each state are a little different. And so some sumps, even though there are sumps in place, they may not have been tested because the rule didn't require them to be tested.
Oh, I see what you're saying. Yeah, yeah.
So we need to always remember that testing and regulations and things like that are usually based on the minimal standards and not the most not the maximum standards. So minimal standards probably a lot less than what we would think.
Okay. Thank you.
So that's a good question. The next thing is let's get into the science of this hydrostatic testing. So we've kind of decided that we really need to have a test that meets a certain criteria in and we wanted to meet that criteria 1/10 of a gallon loss per hour. That's if you'll look at this brass fitting, I've got an enlargement of it. If you'll see, there really is a small hole in the top of that brass fitting, it's a precision orifice made by a company called O'Keefe.
Hmm.
And so what that does is that little hole is you can simulate a leak of 1/10 of a gallon loss per hour in 8 feet of fuel. So and so in other words, this is how you simulate a leak whenever you're doing an EPA third-party test. And that orifice is about 130 microns in diameter. To give you an idea how big a micron is, you can put 93 billion square microns in 1 square foot. So pretty small. And the numbers below that are the actual calculations that are used to determine the size of orifice. So if you want to get into something like that, please send me an email. I can sure discuss it with you. It's just this is all math. Some of it's high math, some of it's just regular everyday math. So another thing that we did is we wanted to test sumps in the way that it was accepted, which was using water. And but we put a um, little camera inside the tanks to see what was happening whenever we had a failed sump. So these are photos of water entering tanks, and they're entering from when you're testing the sumps. So this is a leak of over 1/10 of a gallon loss per hour, and if you can see that little drop there, it passed a 1 hour hydrostatic test. Why? It did drop 1/8 of an inch in that 36-inch diameter sump within that period of time, or whatever size sump that was. This one, you can see the liquid is traveling down the side of the tank. So here we're seeing that if you're testing a sump and that sump is leaking, this is that water is leaking into the tank, which is mixing with your fuel. And remember, we talked about just a 5% failure rate is that's 6 million gallons a year. This, you can actually see the drips of water. If you could see my arrow here pointing around some of those.
Man, that the tank top is full of holes, pinholes, but
Well, you
holes.
would think so, but you know water travels. So if
Oh,
you've got
okay.
an opening, and another thing you got to think that this is really a small area right here from here to here.
Okay.
So
Oh, so it's dripping from one point, running down the side of the tank, and then dropping.
correct.
Interesting.
So it's water does travel. It's not just falling straight down.
Gotcha.
This one you can see it's a pretty good amount of water that if you look at the red arrow, it's significant. It actually passed the 1 hour low level, but it didn't pass the full sump test. There are some other problems with water, and this is not necessarily just from testing. We noticed in a lot of tanks whenever we inserted our camera, we saw a lot of damage to fiberglass from water, from chemicals, from the biologicals in there, and so this is you can see some of this damage to the top of this tank. This is a steel tank. We can see a ball float down at the end of this tank.
Uh-huh.
The little spots and everything are those are biologicals. It's also chemical corrosion due to the biologicals, and so it's we learned a lot of things while we were studying the interior of tanks. We also looked at hundreds and hundreds of subsurface investigative reports, that gave us contamination problems, in the soils and the groundwater. This is something everybody sees. If you're testing a tank, you've got a leaking O-ring, so that you see the bubbles on this. Well, if you were testing a sump in this case, that water would be entering through that leaking O-ring and going into your tank and into your fuel.
Hopefully they'd muck out the mud before they did the test.
Yeah, really, it's true, and some of these are really raw photographs showing you the real thing. This is not made up. So this is one very interesting. As you can see, we're looking at the inside of a sump. There's groundwater on the exterior of the sump, and it's leaking. So this is what we would call maybe a reverse hydrostatic test, but think about a submarine. Every day of its life is being reversed. You don't want it to be tested with the water on the inside. I promise you, it wouldn't be healthy for you. So, groundwater does influence a hydrostatic test. No matter if you want to talk about it or not, it's going to influence the test. And then the other thing with hydrostatic problems is, freezing temps, frozen soils. It's impossible to do a hydrostatic test in those cases, uh, which is pretty easy to see. The regulations did allow for, positive pressure and negative pressure vacuum testing, and we noticed in our studies that increased nitrogen and CO2 content in the soils, moisture content, regulation, which is something, if you study glaciers, you would know what regulation is. It's the pressurization of that ice as it's a frost heave, surficial frozen soils. They actually can assist in a vacuum or a negative pressure test. So we found out some very interesting things as we were going through this process. There are other problems, obviously, Ben, that they're even to the point of civil and criminal problems where folks are dumping contaminated water out on the concrete. It gets into the storm drains, and that's just a complete no-no. Liability from RECRA, it's probably going to be more significant in the future. Basically, anyone that has handled that contaminated water could be considered responsible. for it. There are also unknown factors that we determine, such as the possibility of having to shut down the fueling facilities for test. Those pumps vibrate, and those vibrations cause water to move up and down, so how do you measure an eighth of an inch in those cases? And then the other one is that, we discussed briefly, groundwater definitely affects testing sumps. So we started looking for a better way, and during that process, it took us 5 years to develop that. The industry has never been happy testing sumps and spill buckets with water, and that was pretty evident at one of the PEI conventions right after this was made a national rule. Very, very unhappy folks, testers, tank owners, everyone unhappy with having to test with water. Do we want to leak? No, we don't want to leak, but I mean, there had to be a better way. So we developed Dri-sump, and we've got a pretty good pedigree. It's been tested to extremely stringent EPA third-party testing, Ken Wilcox Associates. We're heavily patented in the United States and internationally. It's been evaluated and published by the National Work Group. Thank you, Don. It's accepted globally. Sump manufacturers are now publishing the Dri-sump technology for their own products, and the standard 823 for repair practice it will be updated this year, very soon, as I understand, just any day now. So we will also meet that requirement. So we're meeting the language now of both the industry standards RP 1200 and the NLPA standard 823. And it wasn't inexpensive to do this. This was not a fly-by-night venture. These are a couple of our CNC machines that we use to make our VSTs, or vapor stimulator tubes. So let's get into testing and problem solving. So with Dri-sump, we can test all types of sumps and spill buckets in any types of soils, any types of conditions. We can test concrete sumps, containment or concrete berm areas, double wall sumps, both primary and the secondary walls. It doesn't require a temporary test boot, which you have to have for water testing.
Yeah.
Because we're not trying to hold the matrix inside the sump. We can test all types of chase and rock guard piping conditions and piping. It can easily replace the older helium leak pinpointing test. If you're, for that type of thing, it's optional connection via the interstice for pinpoint leaks in any kind of vessel. It pinpoints leaks in any kind of single or double wall piping, including even electrical fittings and conduit. It's easy to install for new construction, pre-bury testing for all secondary and spill containment. So you can actually test before you cover. And then for repair, it's a very fast test for sump repairs. So it solves a lot of problems for sump testing. And one of the huge benefits of Dri-sump is it's 60 times faster than a hydrostatic test. As I mentioned before, a hydrostatic test, once you start the test, it's 1 hour. Dri-sump is certified in 60 seconds. So that's huge.
Dri-sump is faster, simpler, more advanced, and a regulatory accepted alternative to costly hydrostatic testing of containment sumps. The test only takes 60 seconds, uses no water, and creates zero waste, meaning no additional waste disposal or water removal fees, and no need to close down your site. Dri-sump uses a heavy aerosol to fill a 250-gallon sump in about 10 seconds. An air generator pulls the soil gases from around the sump into a viewing chamber. A laser is introduced into the viewing chamber. If a leak is detected, you will see a green laser line. If no leak is detected, a laser merely makes a dot. The test is only 60 seconds or less. Dri-sump containment testing. Fast, convenient, laser accurate.
So that gives you a little short introduction into dry sump testing, and it's really just that simple. Um, it uses no water, it creates zero waste, and so once you step off the site, you've left that site completely environmentally clean, and the test is 60 seconds. The equipment's simple, has a small footprint, so we're not taking up a lot of area so your fueling customers can continue fueling while the tests are being conducted. Uh, from the starting on the far left-hand side, those are the view chambers. They have borosilicate glass viewing ports that we can introduce the laser into those. We can also use those to record the result. The next line is the air generator. It generates about 28,000 cubic feet a minute, and we create about a half a PSI of negative pressure through our patented Venturi. The next line at the top are the fog machines or the aerosol generators, and that's basically what it is. We modify these fog machines so that they can use our dry sump elixir, which is the fluid that's used to create the fog. It's completely safe. We'll talk about that in a minute. Then we have intrinsically safe lasers that are used to introduce the laser dot to see if we're picking up any of the particles of the fog inside the view chamber. And then, this is the rest of our equipment right there. So let's look at a typical test using this equipment. So we've got the aerosol fog dispenser. It creates that fog. The fog fills the sump, and it fills it in just a matter of seconds. If there's a leak,
And Danny, if I can interrupt for a second, is the fog is heavier than air. So do you need to worry about sealing the tank top sump, or does the fog just simply, float to the bottom of the containment sump? How do you keep the fog from escaping the sump kind of accidentally?
the fog is slightly heavier than air,
Okay.
Ben. That's one of the attributes that we had to have. We couldn't have it just floating away. So you'll see in all of our marketing, we have fog going everywhere, but really it's you can shine the laser into that sump and you can tell exactly whenever it's filled with fog, and it
I see.
doesn't have to billow over the top like we do for marketing. But um, it's heavier than air. If we do have, 20, 30 mile an hour wind while we're testing, which that's not uncommon in some places, you can just place the lid slightly over the top of it, leave it open,
I see.
and that's all you have to do. So nothing has to be sealed for this test. We can test any type of open top vessel with it.
Gotcha. Thank you.
Um, so once that happens, we're going to pull negative pressure or vacuum in the backfill around that sump, which creates a real gentle negative pressure against the wall of the sump. And by doing that, it's going to want to equalize with the positive pressure on the inside of the sump, the negative pressure on the outside. It'll try to fill up any of those little small holes down to, that 1/10 of a gallon loss per hour type hole. And we'll pull it into the vapor stimulator tube, which has slots in it, looks like a little miniature well. And so we pull it into there. It ends up going through some hoses and ends up in the view chamber. And then in the view chamber, we introduce that digital laser into the top of it. And if you see a laser dot, it means it passes the test in 60 seconds. And sometimes within that 60 seconds, if it fails the test, you would see a line. You don't actually see any fog inside it's just picking up the particles and reflecting off of those particles.
And those are hydrocarbon molecules.
No, no, those are our fog, Mark.
Oh, okay. Yeah, yeah.
It's
Okay.
just the
Gotcha.
fog. Yeah,
Okay.
we're not touching the system in any way. And you got to remember, a sump also is designed to be empty. So it's not a tank. It doesn't contain fuel. I mean, it's not designed for that. It's designed as a temporary holding compartment in case there's a leak. Otherwise, it's empty. So we're filling it, instead of filling it with water to test it, we fill it with that heavy fog. So as again, I said, the facilities left no environmental impact after the test. There's no water to dispose of. The fog dissipates in about 10 minutes and just turns back into normal air particles. So absolutely no uh, waste whatsoever.
Danny, what's involved in putting in the simulator? Or maybe you're going to get to that. Yeah, there you go. Okay, thank you.
Yeah, right. Well, I had you on that one. So the little tube is the only thing it has to be installed if it's a new site. It takes about 10 to 15 minutes to install one of these tubes. As you can see there, it can be installed with a little core drill or either a hammer drill. It takes just a few minutes to drill that hole. As you can see, it's pretty clean. And then we use a rubber mallet in most cases just to drive it down into the backfill. And it's just really that simple. And then it's sealed at the top, so it's left there permanently. You end up with something a little about the size of a quarter. The cap is about the size of a quarter. And we don't have any issues with contaminants or fuel spills getting into that. This technology came from my vapor monitoring technology. We've got probably 250,000 vapor wells that are installed across the world. So we've never had a spill that impacted one of our wells. So it's kind of a moot point. And the beauty of the VST or the vapor stimulator tube is that the bottom of that tube can be above all the piping. And in a sump, you can see your piping, you can see the level of it. So you don't have to install that tube down into the piping area. You can actually be above all the piping. So it just gives us another little bit of safety there to not damage the existing UST system.
We did have a couple of questions. Maybe you answered this. Are VSTs placed randomly around the sump? That's one question.
Okay, they are placed not randomly. They're within usually about 1 to 8 inches from the edge of the sump.
Okay.
And an STP sump, there are two. They're opposing about 180 degrees across from each other. A UDC or dispenser sump just requires one, and a spill bucket requires one. They're approximately 18 inches, 15 to 18 inches in length. And the ones in the STPs are about 36 inches in length, and that's depending on where your penetration points are. If you've got really really deep sumps, let's say in some of the colder climates, you can install a solid piece of PVC pipe on top of that VST to drive it down a little further.
Sure. And then does it matter relative to the penetration fitting? So does it have to be near a penetration fitting in order for it to work?
No, it's an active system, so we're actually creating that negative pressure all the way around that sump whenever we pull the vacuum on it. So we're not waiting for something to happen. We create it, and it's very reproducible results that we can get. As a matter of fact, we've done two EPA third parties through Ken Wilcox Associates, passed both of them with 100% accuracy. So that's in all types of soil. We tested in actual real soil conditions with pea gravel, sand, and 95% compacted clay silt. So
And
it doesn't matter. It works on any type of soil.
and so they also asked what controls the number of VSTs per sump. I'm guessing the two per sump is recommended by your company.
Two are installed for STPs,
Yeah.
one for a spill bucket, and one for a UDC. That's in our training, and all technicians, anyone that does Dri-sump, they have to be certified through Accent or through us, and we run them through a really good training program, and then annually they retest and and we keep them up to date on any changes, anything to the system like that. So the equipment has to be inspected annually also. So we're pretty stringent about making sure the technicians are up to speed on everything and the equipment is adequate to do the job.
Here's an interesting question. I think I know the answer to this. Where'd it go? Uh, this is designed to look for leaks that go into the ground, not the tank, correct? If there is a crack or hole that goes into the tank, the product will not detect that, correct? I think the answer is incorrect. So if you have a sump that's leaking into a tank and not into the ground, would a dry sump test find it?
We can also test we can test the inside of the tank also in the ullage area. Yes, we can test that if we need to do that.
Okay. So if like a
Uh,
fitting, like if a fitting from the sump into the tank is loose and product is getting in,
We can test that part.
okay,
Yes.
but it'd be a different test than a standard outside the, oh, interesting. Okay. Okay.
Yeah, it's there are several ways. You gotta think about it, Ben. We've got several different procedures for different types of tests for each piece of equipment, and that we're testing. So yeah, it's more complicated than just pulling a vacuum, but it's still a very simple test.
Sure.
If you'll notice in our equipment, one of the things that we wanted to do is we started out with all the gauges and the valves and everything that any other test method that you would from line testing, tank testing, whatever you would see, but we started trying to eliminate, do we really need this valve? What can we do to replace this valve? What can we do to replace this gauge so that the technician doesn't have to be concerned about it? It's just something that's automated for him. So that was some of the things that we did in our design.
Okay. And then someone asked, can dry sump pinpoint where the sump leak is located?
Absolutely.
Okay.
And sometimes in a matter of minutes. We were just at a state agency doing a demonstration a couple of weeks ago and uh, located a leak in a double wall sump and pinpointed it. We were able to fix it and or the contractor was and retest during the same process there. So very fast. With water, obviously, the only thing you can do is wait until the water drains down to wherever the first leak is. And, that can take hours. So this is really fast.
Yeah.
This is showing some photographs here of filling the sump with our aerosol. And the one in the top, like I said, that's one of ours. We're showing that letting the fog roll over the top of it. But that was actually in about a 15, 18 mile an hour wind on that top one up there. But it fills any open top sump. It takes just a few seconds to fill it. The particles are submicron. So in other words, one of the things we had to do is it had to be in submicron particles so that we could actually pull those particles through a leaking area in a sump and through the backfill and into our view chamber so that we could pick it up with the laser. And then, like I said, actually after everything you're through testing, it dissipates back to normalized air particles. The fog is pH neutral. It's inert. It doesn't conduct electricity. It contains no hydrocarbons and is made entirely of food grade chemicals.
Hmm.
So it's very, very, very safe.
It's good fog.
This is a negative pressure test. As you can see, this is just what it looks like when you're connecting and getting ready. This is you're seeing the technician who he's introducing that laser into the view chamber. One of the neat things about the view chamber, it's a very visual test, so you can have more than one person there viewing the test. It is a visual, so it's easy to see if it's passing or it's failing the test. And it's fast. It's 1 minute. You don't have to hang around long. This is what it looks like looking inside the view chamber. This is blown up a little bit so you can see that small laser dot. And as you can see, it's just a dot. So this would be a pass after 60 seconds. And this is what it looks like if you have a fail. And you're not seeing particles there's no fog in this sump. You're just seeing some reflection off the walls of the view chamber, but that's what it picks up. So this would be if it failed the test. So let's look at an actual one and see what it looks like. So that gives you an idea of what an actual test looks like when it fails the test. Some of the things you can do with Dri-sump, it can be installed during new installation. So this is all new installation. The bottom one that you see, the large Xerxes type color there, that's I think those are 350,000 gallon tanks in
Big ones.
Texas for their generator system, which is up on the sixth floor. They're huge. There's I think a 4-inch fuel line going to those generators up there for AT&T.
Here's a question
So
for you.
as you can see,
Oh, if I
yes,
can
sir.
jump in, does it work underwater, i.e., dry sump that is surrounded by a high water table? That's an interesting question.
The we're the only test method that has a groundwater procedure.
Okay.
So our groundwater procedure takes into account every level of groundwater that would be possible at a location surrounding a sump. So and you can use our groundwater procedure for hydrostatic testing. It's a good procedure for any type of a sump test.
So, but if the tank was underwater and the water was right around, near the collar top of the containment sump, could you do a dry sump test?
In that case, Ben, and of course you could go through our training and see that, but in that case, part of that sump would be tested hydrostatically, automatically if you had groundwater surrounding that sump. One of the things you
Yeah.
have to do is empty the sump. You're inspecting that sump. If you don't have any water coming in, and while you're doing other things, you, you can you can even test it for an hour and see if you get any water intrusion inside the sump. That would actually be testing that sump. Our VST can be used as a piezometer, or so that you can measure the level of the groundwater around that sump. So you know the exact level of groundwater using our VST tube. So
Oh,
it's
okay.
very precise, and that was the whole concept, to be very precise in this type of test. This is using our technology for instead of using a helium test. I don't know if any of you are familiar with helium test, but it's basically you're drilling small 1/2 inch holes in the cement, hopefully close to the piping area. You're injecting helium into the pipe, and then you take a sniffer and you sniff at each one of these holes to see if you're picking up any helium. In about 30 minutes, you're done because you've saturated the soil with helium. But with Dri-sump, in about 10 minutes, you can start all over again. And instead of a sniffer, we're using a digital laser. And if you look at the top right-hand corner, you see that little short green line in that little 1/2 inch. That's a 1/2 inch hole through the cement. And so we found the leak, and it was located in a T-fitting under a sidewalk at this particular location.
Question,
Uh,
can sumps with visual fails be tested, i.e., failing sump boots?
no, let me hear that question again.
I think I understand it. Can sumps with visual fails, in other words, like you can visually see the hole, be tested, i.e., failing sump boots? So,
Okay, if in any sump test, whether you're doing hydrostatic, vacuum, or pressure, the first part of that sump test is to inspect it. Anything that you find that fails the inspection, it fails the test. So in that case, that would have to be repaired before you would continue with any other type of test. So in
okay,
that
so
case,
even before the test even starts, you're doing a recon to kind of see what you're looking at before you actually fire up the test.
absolutely. And that happens. That's a requirement of sump testing is to do an inspection at the beginning. So that's very important to inspect that sump first before you ever start a test. Same
Gotcha.
thing if you're doing a line test, you pressurize it up. If it doesn't hold pressure, you're really not going to perform the line test, but you're actually failing the line, aren't you? Even though you haven't performed a test, you just tried to pressurize the line up. So it's just a process that you have to go through the inspection. This is testing 25,000 gallon ASTs. So we're testing through the double wall, through the interstice on these tanks to see if they were tight. This was set up for a nitrogen, um, uh, so that they could put nitrogen blanketing in these tanks. This is testing a spill bucket. Here again, where you don't have to have this fog going. Hey, it's kind of interesting though. We never had a fire department. We never had a 911 call that I know of anywhere in the United States. So that was one of the things we were concerned about. This,
Someone had a question. Question mark one. I'm assuming they mean one test port for UDC if we have pass-through piping. In other words, like a transition sump. So do you just need one test port for a transition sump, or is a sump a sump a sump, and you have two per sump?
our work group said published work group says that you can have one at a UDC. However, in our training, if you have a pass through, it's not, you can easily put one on both sides.
Okay.
So if you're comfortable with that, what it does for you, it allows you, if you do have a leak, you can pinpoint it quicker. One side will fail faster than the other side, so you know which side to start looking at for um, a, a, a penetration point or something where you've got a crack or something there. You would know quicker for your leak pinpointing. So it does help on that, but it's not necessary for the test itself. This is testing a dispenser sump. Let's see if I can start it back up. Oh, sorry about that. We'll go back to it. This is testing a dispenser sump. And these are all demonstrations. So this is testing an STP sump. As you can see, the wind was blowing a little bit, so we put the lid partially on the top of that one.
Did have a question. Who inspects this equipment annually, and where is the documentation for the inspector to review? So if the inspector wants to know that your equipment is, inspected, calibrated, what's the program there?
They have to there's a sheet that's filled out annually, and then two short videos that we require to be sent to us. So
Oh,
one of them is we want to see a manometer reading on the venturi to make sure that it is adequate, and then it's an inspection document that if they want to see it, just tell them to contact Accent
okay.
and we'll be glad to discuss it with them. But we annually certify the equipment after we get those two videos. We're happy with those, and the inspection sheet is completed.
Interesting.
And if anything needs to be fixed, repaired, it's real simple. The equipment doesn't have to come back to us like a lot of test equipment. The inspection with the videos is done all by the technician and then sent to us for review.
Someone also asked, can we use this to replace a tank tightness test? Would tell us the same thing, correct?
No, you can't do a tank tightness test with this system.
Okay.
We'll pass this one. This is just showing that this is kind of interesting. So what we're doing here, let me see if I can turn that up. Turn the sound down here a little bit. So what we're doing here is we're showing how fast the fog moves through the he's introducing fog into a VST, and it's traveling all the way through this in a matter of seconds through all the backfill soils. So it's a really it's very fast. I don't know if you can see that fog coming up through all of these little small holes. So it travels through backfill really, really fast.
Hmm.
And then someone asked about water. Uh, well, we don't have this available, but this is what it will do. I'll show you here real quick. So this is 5 feet down. We're introducing the fog 5 feet down. As you can see, it's traveling through the water and coming up out of the top of the water. And it's just dry fog whenever it exits the water. It does the same thing in fuel.
Hmm.
What this does for us, if we're trying to test the top of a tank and find leaks in the top of a tank, we can actually inject our fog into the liquid itself, and it will end up into the ullage area and exit through any holes in the top of that tank. And we can discover all your holes in the top of a tank that way pretty fast. See, hold on a minute. Here we go.
Well, we got to.
And that's pretty much it.
We've got a whole bunch of questions here. It is about the top of the hour, Danny. That was really pretty cool. I want to go through some of these questions.
Okay. Let me unshare this.
Well, I keep that up so people have contact information for you, if you don't mind.
Okay, I sure will. We can do that.
Does the presence of water or more impenetrable backfill mean you have a longer test time? So in other words, if there's water or heavy clays or something like that, does that change the testing time?
No, the short answer is no. The longer answer is we did all of that in our EPA third-party testing. We tested in 3 types of soil, and instead of a laboratory setting, the work group asked that we would do the same thing in a real-world setting. So we tested with a deep 5-foot sumps in sand, one in pea gravel, and one in 95% compacted clay silt.
Hmm.
And our VSTs were installed as far as 2 feet away from the edge of the sumps. And the difference between the clay and the testing in the clay and testing in the pea gravel was 2 or 3 seconds.
Wow, fascinating. Okay. Could you add fog to the interior of an empty tank and check the interstitial space as a troubleshooting tool?
Yes, we're working on an EPA third party for interstitial testing this year. So we'll have that available to the work group at some point, hopefully before the year is out, and maybe next year they will have that published for us, hopefully.
Okay. I have heard 3 different chemicals used for your testing: inert vapor, helium, and nitrogen. What is the reason for using different gases for the tests?
I didn't really understand that question. I'm sorry, Ben.
Oh,
Repeat it.
I've heard 3 different chemicals used for your testing: inert vapor, helium, and nitrogen. I think you're talking about 3 different tests and 3 different gases. What is it?
Yeah. The only
Yeah.
thing we use for our test is the heavy aerosol fog. But in our evaluations and in our research and development, we used everything from argon, carbon dioxide, carbon monoxide. We used anything we could come up with, nitrogen, several things, and we used FLIR meters, $100,000 FLIR meters to see what happens using that technology. We used different types of equipment. So that was in our research and development. It was a huge undertaking. But no, we use just the heavy vapor aerosol fog for our test matrix.
Okay. And you have a certification program or recertification program for the techs, or are they one and done?
Yes, every technician has to go through recertification annually. It's via a test, an online test, or they can always come back and do a refresher at our facility.
Okay,
But it's annual.
great. There's a lot of good questions here. I appreciate that. Can the test determine what penetration is leaking? For example, if you have three
Yeah.
product entry boots at the same site, can you tell which entry boot is leaking?
Yes, yeah, the short answer, yes, you can. The way it's done is taught in training. We use what we call pulsing the fog. So we're just putting a little bit of fog around each fitting and we're testing it. Let's say, for instance, if the test fails in 8 seconds, then we're looking for a failure rate in 8 seconds. So we're going to put a little bit of fog around each fitting, run it for the 8 seconds, and then move to the next one until we find the one that's leaking.
Oh, okay. Interesting. Okay, so you kind of go from like a gross leak, knowing that there is a leak in the system, to being able to isolate, like, interesting. Okay, that's super cool.
Yeah, do the same thing. A lot of them, a lot of one of the problems we have in this type of testing is we have electrical conduit inside of sumps. If you're testing with water, then the water is going to leak into the electrical conduit. So what we do is if we find that as a problem, then we isolate that electrical conduit by just putting a little sealant on it, just a little temporary sealant on it. And then if it passes the test, we know that the failure was in the electrical conduit fitting, which they're straight threads. So they're not designed to be liquid tight or completely waterproof.
Okay. Someone asks, is Dri-sump approved in all 50 states? Maybe a involved answer.
Yeah, that is an involved answer. We are not approved in Connecticut. We're not approved in Maryland. Um, Delaware has a rule change, and as soon as they finish that rule change, it's our understanding that we should be good to go in Delaware. California has changed their rules this year. It comes out 1/1/26, and they told us that they're putting it in their rules with language so that you can use Dri-sump throughout the state of California as early as 1/1/26.
But
So
part of the limitation, if I understand correctly, is when the federal rules came out, it didn't really anticipate this technology, and so it didn't. I mean, there's regulatory reasons why a state may not support it because the rules don't support it, but then there might just be that the agency doesn't like or doesn't understand the technology too.
yeah, every state, the rules can be more stringent than the federal rules, and some states have had rules in place for many years um, that require some type of testing. So, in those cases, what was their alternative? It was hydrostatic testing. You can't put a lid on top of a sump and test it with pressure. Sumps are not designed to carry that type of pressure. So the other only kind of alternative was basically hydrostatic. So this is a very sophisticated technology that came into effect after the rules were written, and we call it, and the rule calls it alternative testing methods. So it is alternative to what the rule originally allowed, which was mostly hydrostatic testing.
Right. We've got a ton of questions here. We are a little bit past our time. What I think I want to do is I'm going to gather up all these questions, Danny. I'll email them to you, and then I can email them back to the group. There's some really good technical questions here. I want to be mindful of people's and your time as well. Why don't you yeah, so maybe you can drop the last screen. We can just have a couple of parting words here. But these are some of the best questions I've had all year so far. So thank you for everyone. But I am a little short on time. Um, Danny, they can reach out to you directly. I'll be providing everyone your contact information if they didn't get it on the show here. And then I'll be at the National Tanks Conference in Spokane this September. I think, Danny, your group's not going to be there, but I can certainly relay information. Your company will have a booth at the PEI NAC show in Chicago this October, correct?
No, we don't have booths.
Oh, you
You
don't?
can
Okay,
go
so
to
I
some of
missed
our,
that.
our folks that that are associates, and they'll have some test equipment at some of those booths.
Okay, great. Yeah,
As a manufacturer, we just don't have a booth, Ben.
gotcha.
It's better to have it there.
Yeah. Okay. Well, we went a little bit over time, but I think that was because we had such a great interest in your presentation, Danny. That was really a great breakdown of kind of a technical process, and I appreciate you explaining things in a layperson's term. I know we had a lot of service providers on the line, a bunch of operators, a bunch of regulators, and I just think that was really helpful information. I really appreciate your time, and I appreciate your contributions to the industry. It's really cool to see. And so I gotta ask. So Danny, did you just did you dream this up? Did you like sit up in bed one night and go like, oh my God, like a fog machine and a laser, just how where did all this come from, if I may?
Well, I always say
Is
the
it a
good Lord
trade
gave it
secret?
to me. I don't think I'm that smart, Ben. I think the good Lord gave it to me is what I really think. But I started thinking about it in 2010, whenever we were working on the RP 1200. And one of the issues, being a groundwater professional, one of the issues is that we didn't know how to include groundwater studies into this type of testing. And so that's kind of where it started. And then obviously, having a background in soil gas analysis and things like that, that gave me a lot of benefit.
That's great. Well, again, I appreciate your time, Danny. A whole bunch of questions here. I'll gather all these up and I'll shoot them off to you. You can send the answers back to me, and I'll push it out to the group so that they can certainly follow up with you and your team if they have more questions. So I'm gonna say thanks again. I'm gonna hit